pleasure. Amazing speakers during the next hour. First, a little bit about AIFS. Some of you have already been here over the last hour starting the hackathon. And for the speakers, I want to let you know that we have some amazing students here. And we've come up with the term, the DCSM, the Designated Computer Science Major, who is going to be a part of each team, plus the people have different amazing majors with biological systems engineering over to other ag engineering majors. So great group here for the hackathon getting a kickoff. Anyway, why are you here? What is AIFS? What does this sign mean here? AIFS is a federally funded institute that is sponsored by the U.S. Department of Agriculture. We have received a $20 million grant over 5 years to help AI flourish in the ag system, the food system, okay? And with that grant, we fund 25 or so researchers that are faculty and 25 or so graduates and postdocs at UC Davis, Berkeley, Illinois, University of Illinois, and Cornell University, and our partner UCANR, and one of our speakers will tell you about that in a bit, as well as the USDA ARS, Western Human Nutrition Center, right here based at UC Davis. So a lot of action going on. Over the past 3 years of our existence, we've had about 48 projects that have done some amazing things. Okay, that's what we have been funded with and what we have been doing. We also have an outreach mission. You have been communicating with Ashley, who has done an amazing job organizing this. Please give her a hand. Ashley is our education and public outreach coordinator, and our mission is to let you know about what you can do for jobs in the ag sector. And you're going to have some talks about that just coming up right here. So a few slides here, just a little bit about the speaker series. We have speaker series occurring rarely. And this speaker series today is the industry's perspectives on ag and AI as a career. AIFS, we have a vision of a healthier society and sustainable planet through robust food systems. And our mission is to develop and leverage transformative AI for the ethical production and distribution of safe, sustainable, and nutritious food with your resources. There's all of our partner logos there. And we have these research programs going on within AIFS. And I'm going to ask Mason to raise his hand. He's the cluster lead for food processing and distribution, or ag production. There it is right there. And we also have nutrition, food processing, and molecular breeding as well. Johnny, you do some research in molecular breeding. Okay. And core AI technologies span all of our research, as well as ethics and socioeconomics. These are our three research thrusts: the infrastructure, the food system supply chain resiliency, and food systems to improve human health. And letting you know, on June 26th, we'll have Dr. Justin Siegel, an AIFS-related researcher from the Department of Chemistry at UC Davis, as a guest speaker. And both these today and the next one are held here at the PSEL building, the seminar room, with a virtual option. Okay, so that's a seminar series. You can contact us at these contact infos. So with that, we're going to have 4 talks here. I could take the whole hour with bios for each of these speakers. So I'm just going to introduce them, and their story will essentially be their bio. So it's my pleasure to introduce Rikin Gandhi, who's the CEO of Digital Green, and he will take it from there.
All right. So yeah, at a young age, I was inspired by astronauts as these heroes who combined brains and brawn and were discovering the new frontiers of science. And so I looked at these astronaut biographies, and I sought to put together my own by studying computer science in undergraduate at Carnegie Mellon, doing grad school in aerospace engineering at MIT, getting a pilot license, getting eye surgery, and then was about to enlist in the US Air Force when I had some friends who were starting up a biodiesel venture in rural Maharashtra, which is on the western part of India. And I landed up with a very different sort of hero, the Indian small-scale farmer who earns just $2 to $3 a day, but produces the second highest farm output in the world. And they are having to navigate all sorts of challenges from climate to gender inequities to volatile markets. India, as you might think that a lot of folks are moving out of farming, but actually in the last 4 years in India, the number of farmers has increased. It was 200 million farmers 4 years ago, and it's now 260 million farmers today. And that was accelerated as a result of COVID, where a lot of the urban population of folks who are into domestic work and other such jobs, as a result of the shutdowns that took place in India, were forced to migrate back to their home villages, and where they found new sources of income back on their farms. And interestingly, like they also brought the technology, which was mostly in the form of smartphones, that they had gotten familiar with in these urban Indian city settings back to these rural areas. And so it's been a combination of COVID and that reverse migration that's taken place, along with the fact that there's one of the cheapest mobile data networks in the world in India called Jio. And it's basically 1/5 the price of data costs than even China. The US is, of course, relatively much more expensive data. But so that's what's really enabled these farmers to come online. You might be familiar with agricultural extension. We will hear from Gabe in just a little bit about the US extension system, especially here in California. But just to share, agricultural extension abroad has borrowed a lot from the US model of agricultural extension. So basically in the 1960s and 70s, during what's called Asia's Green Revolution, governments around the world, including the US government, partnered with other governments like the Indian government, and they took this land grant institution model that you are a part of, being part of University of California, but also, as is many of these others, like University of Illinois, Cornell University, that are part of the AIFS network, wherein they have these research and academic and education centers, and they couple those with extension agents at a county level to be able to take the latest research and innovations out to the field to farmers of various kinds. And in the same way, in India, they set up state agricultural universities across the country, and they set up a network of more than 200,000 odd extension agents who followed a particular approach of conducting field demonstrations of new varieties of seed. During the Green Revolution, it was dwarf varieties of rice and of wheat, and the introduction of bore wells and irrigation, along with fertilizers, ended up helping to mitigate what people were concerned about of a potential famine in India. And so that's what's kind of considered the Green Revolution. But it's a real challenging activity because even with this large network of extension agents, there's even a larger community that is extremely diverse of farmers that they're trying to serve. And in India, it's just about 6% of extension agents, farmers report that they get information from extension agents as a result. And for these extension agents, they're toiling out in the field and they're often not from these same communities. And it's often a struggle, even just for anyone to be willing to listen to them. And this comes at a significant cost. So in India, this mostly World Bank finance and Government of India supported extension program costs about $35 US to get one farmer to adopt one new practice. What we've been up to for the last 16 years, which started as a part of Microsoft Research. The reason why Microsoft Research was interested in this space, and you'll get to hear a little bit later from Ranveer Chandra, who is Microsoft's agribusiness lead, is that they were interested in seeing, is there a role for technology in this small-scale agricultural community context? And this was back in 2006. So this was pre all the mobile revolution and internet connectivity that I just told you about. And so what we started with was using videos that would be produced by and for farmers. This was quite different from like the traditional way in which the government of India also was and is running a broadcast television program for farmers. They have like a dedicated channel 24/7 just for farmers. But that's really different. It's like professionally produced broadcast type of programs for farmers that reach a really large audience because it is broadcast. But what we were up to was to not produce ourselves, but really create more of a user-generated community of farmers themselves that could create their own videos as testimonials, as demonstrations that their peers could relate with. And then have these facilitated at the time offline using mobile projectors at the places and times that these farmers would often gather, like women's self-help groups that were doing microcredit and savings that they could then watch a video around. And also to collect data and feedback about who watched what video, what questions they asked, and what practices they did or did not do afterwards. And the first question that people ask when they watch these videos is not the economics of the practice, but what's the name of the person in the video? Which village is he or she from? To be able to say that if this farmer that I get to watch on video can do it, then perhaps I can too. And it also creates a bit of a role model dynamic where farmers sometimes apply these practices just to be seen as an exemplar in their communities. So it's now scaled to more than 6 million farmers, not just in India, but in Ethiopia, Kenya, Nigeria, Nepal, and the like. And through some randomized control trials, have been able to show that it can boost farmers' incomes. And we've not done this ourselves. The whole activity of creating these videos and showing these videos is very much married with these existing grassroots level, mostly government, but also in some cases, nonprofit and private agribusiness extension networks of about 100,000. And these videos have been able to cut the cost of extension from 35 US down to like 3.5. Now what we're up to is to try to connect with the advances in generative AI that you all are going to get to play with this weekend in this hackathon, is to combine the power of these local videos that people are able to relate with as their peers and be able to trust with an AI assistant to really put it into the hands of now these extension agents and farmers who are there on the ground to really improve the efficiency of their work and to do it in an open source way, because we don't think that we can create all bots for all people. There's so many organizations out there who know these communities much better than we do. And your use cases that your various teams have identified are going to be a great example of what you can try to do with this open source stack. So I just wanted to real quick show you what you're going to get to play with. Some of you may have already looked at what we have shared as pre-reads before today's session, but so there's an open source stack, which is basically a layer above the large language models. We're not trying to reinvent the large language models. There's way more investment going into its development. We don't have the compute to be able to do that ourselves. But there is, for the agricultural domain, and especially the agricultural extension domain, there's a need to think about the agricultural vocabulary, how you orchestrate between different knowledge sources, videos or weather data or market information or even research information that might be coming out of the Youtsey system. And so through this documentation, you can set up your own bot, basically. You should be able to access this site where you can create your own login for your team leads and your team members. And then you can upload your own content. You can see here, we added some content from Youtsey A&R for different commodities. These are videos, I believe, from related to elderberry production. And you can see what happens behind the scenes in terms of the chunking of these videos, contents, transcripts. And that then becomes vectorized and then queryable by your bot. So you can see a bunch of videos that have already been uploaded in this example, and you can kind of set up your own. And then I can ask questions of it to ask things like, hey, what should I be most careful about when I harvest elderberry? And I can ask follow-up questions about how I can minimize foodborne illnesses. And I can also do that in Spanish. And what you see over here is follow-up questions that are generated by the model to help users know what is this model even for, because we often find that they are challenged sometimes to even think of a particular question they want the answer to. And then it also can do not just text output, but also audio output, so that for folks who might have challenges of reading, they can just listen to it. I encourage you to also use the Slack channel that we've set up. If you have questions as your teams try out this bot and the open APIs and software for yourself, you should feel free to use that channel. Yeah, and this is how it's used in the field by extent agents and farmers. We're just over Telegram and WhatsApp, asking these natural language questions in voice and text form, getting back answers that are a combination of videos as well as dynamic data sets like weather and market information. And where it's a two-way interaction where they can also give feedback, because it's not like the bot is perfect. And there's a need to use their feedback to improve through like human in the feedback and reinforcement learning, ways in which to improve the model's performance to better align to their needs and interests. So for us, this bot is live in the field, not here in the US, but abroad in India, Ethiopia, Kenya, and Nigeria, serving about 12,000 extension agents. It's dramatically changed the way in which people are accessing the content. We have about 80 million views to our YouTube channel, but in this case, people are able to use this bot multiple times in the same week. And these are small farmers who are growing usually a mix of crops and livestock and are encountering all sorts of questions along the way. And they can just do it on their fingertips in natural language. And we find, especially for women farmers who are increasingly doing the lion's share of agricultural work everywhere, they use this 2 to 3 times more than their male counterparts because it's just so easy for them. And on a cost-effective basis, we're finding that it reduces the cost of improving the adoption of climate-friendly practices by farmers by another order of magnitude, down to 35 cents, since now it's much cheaper than even our video approach, where we had video being produced in mold projectors. And our goal by 2030 is to try to expand this to 60 million farmers. My hope is that many of your ideas we can actually be able to take forward and actually bring to life in the field to create an impact with farmers here in California. So that,
All right. Gabe, as I bring you up, I'm going to go to a lavalier microphone. We've got some people in chat saying that our audio is a little low, so we're going to pump you up a little bit as we change here.
Excellent. Well, hello. I won't take too much of your time. I'm really thrilled to be here. So many of you showed up on a Friday afternoon. I'm awesomely amazed that you're here. So it's great. My name is Gabe Youtsey. I am the Chief Innovation Officer for this thing called the University of California Agriculture and Natural Resources. And I'm going to sort of just give a brief explanation of what it is, sort of talk about California and give you the California flavor of what Rikin started. And so I run a program here in California called The Vine, which is really all about innovation for the future of food and agriculture, from California really, but expanding out to the world. In this case, we're actually bringing technology that's being used around the world in India and Africa and expanding it to California, which is really cool. We've got a major food crisis in the world, I'd say generally speaking, and some of the major themes of what drives innovation and technology forward, just broadly speaking. We've got this shrinking supply of production of our nutritious foods that California produces, in particular, fruits, vegetables, and nuts. That's increasingly moving around the world, and our footprint of being able to produce that in California is shrinking. Climate change is, of course, threatening global food production. I probably don't need to say a lot about that. Global populations are rising. We're not getting any more farmland. Arable farmland is decreasing. We've got a huge spike in cost and food. You've probably seen that at the grocery store. It's all the way down to the very bottom of the supply chain. Food and farm production costs are rising. And ag and food innovation can be slow and take more time because it's deeply scientific and technical. And in some cases, other nations are actually ahead of the US. And then ultimately, the poor diets are causing disease and chronic illness. So those are some of the things that drive a lot of these things. But California is on the cutting edge here. And I think, through events like this, we're going to see where there's an embracing of artificial intelligence, but pairing that with biotech applications are driving ag and food innovation. We're also from California really driving national climate change leadership, much more like Europe, and leading usually in policy ways here from California. We intersect top tech sectors here in California, as well as the top ag sector. California is the #1 ag producing state in the United States. We really are thinking about inclusive innovation and thinking about the health and lives of farm workers, small farms, in ways that are really advanced. And I would say creating this new bioeconomy, this new future that's not just tech, it's not just ag, but it's really this new thinking about how do we create an economy for a healthier, more sustainable planet and lives that also is profitable. And California is the world's fifth largest economy. We produce 80% of the U.S.'s fresh food supply, got wonderful universities and colleges, and we already are the global innovation leader. So let me just stop just for a minute, just to talk a little bit about who Youtsey Agriculture and Natural Resources is. We've been around for 110 years, and that's actually somewhat after UC Davis was established. But the goal has always been to extend the science and technology from the university into the hands of the people of California. Every land grant, what's called land grant university in the US has one of these. California's is the largest. We are we're structured in California as part of the UC Office of the President because UC Berkeley, UC Davis, UC Riverside, and now UC Merced and UC Santa Cruz all have a mission to drive forward food, agriculture, and natural systems research and innovation. And the hallmark of what we do is really having people on the campus. You don't get a class from them. They're out doing research. They're doing extension work. They're usually called specialists. We have new names for them now. And then there's people in every county across California that work for the university who work side by side with growers, bringing very practical information like how to produce, pistachios, or what's the latest outbreak of navel orange worm, in really practical ways to growers, and doing demonstrations, doing on-field research that's very, very, very applied. And so other countries around the world, as Rikin said, have adopted the US model to varying degrees because it's worked well for many years. Enter the age of technology and the growing amounts of problems and challenges that have faced California farmers. It's becoming increasingly expensive and difficult to produce food in California. So some of the key challenges that are driving technology adoption here in California: labor costs are going up. It costs perhaps, let's say an average of $20 an hour for a farm worker here in California. In Mexico, that same farm worker gets $20 a day. So very difficult to compete with that kind of labor market. That wonderful climate change policy also produces a ton of overhead for growers for regulatory compliance. Water is increasingly measured and scrutinized and in short supply. So every drop of water is very precious here in California. We always have a variety of pests and diseases, and farmers always have to adapt to new pests, new diseases that are coming at them. For fresh food in particular, but for all other kinds of crops, food safety concerns. You guys read about food safety outbreaks as well. Those are issues. Market competitiveness, predominantly with South America and other countries, has been an issue. And then just the straight up cost of production. So the thing that grower were asked anytime a technology is presented to them, will it save me time, money, or a headache? Okay. So if it doesn't do that, then they will not buy it. And technology is coming at them in droves right now. So there's different kinds of solutions that are coming at growers. There's new robotics and automation solutions. This is a FarmNG robot, which UC Davis has one of these. And farm workers actually laid a board on it and laid on their bellies and use it to pick weeds. That's a real picture. There's new technologies for dairy, for methane, and for feed control. New production systems like controlled environment ag, and food processing, new different kinds of bioproducts and biomaterials, new sensors, all these things. So as Rikin really pointed out here, a really cool and simple tool would be to harness the power of a tool like ChatGPT that has really specific and highly accurate information that the growers could use. And then the growers use an army of different types of people in California to help them. They use pest control advisors. There's people that are specifically hired to advise them on how to address pests. And those people and the farmers could really use a tool that has highly accurate, relevant information for them in an app to provide information about what pest am I seeing? How do I address that? Because there's a range of pest control advisors. There's certified crop advisors and irrigation advisors who advise farmers on when to irrigate, how much to apply, how to approach that, what kind of fertilizers to apply, what kind of other inputs to apply. So the farmers themselves have a lot of expertise, but they also hire a lot of consultants. So that's a little bit different, I would say, than the international model. So having apps like Digital Green that are really fine-tuned with the data from California that are specifically aimed at the California farmers and growers and consultants would be really, really, really valuable. Also, another group that is often overlooked here, what about the workers? In California, almost every single worker, for the most part, is from Mexico or Central America, almost to a person. So they also don't have good sources of information for matters that concern them. And that's one of the other issues we want to tackle with these things. But there's issues there because, you think everybody from Mexico or Central America speaks Spanish, not so. Oftentimes they speak indigenous languages like Zapotec and Cliqui and Mixteco and other languages, and Spanish is not actually even their first language. So adapting to those indigenous languages and cultural practices using these applications is a big challenge. And if that can be cracked to provide sort of really useful, timely information to the workers, the supervisors, the consultants, and the farmers with the information they need in the languages they speak, that would be a really valuable addition of technology for the future. So good luck. And I think you're going to hear more from some of these farm advisors who do some of this work day to day over the next couple of days. And we're really excited. There's a lot of information if you want to get some data sources for the apps you're working on at ucanr.edu. And so you can look through a whole host of information if you want specifically pests, IPM, Integrated Pest Management, ucanr.edu, gets you a huge wealth of different kinds of information about pest management in California. So I'll stop there and thank you very much.
Okay, great. Karl, come on up. We'll get you going here. This is Karl's from Pheronym, and AIFS puts some career exploration fellows at their company. Multiple companies. They have Karl here, so go ahead and put on your lavalier mic while we get your cover started.
Okay, so as I said, I didn't really have time to make up the deck because I was doing other things, namely working on getting my product ready. So Pheronym is an ag biotech company. We use pheromones from microscopic roundworms called nematodes to control agricultural pests in the soil. Quick survey, anybody here heard of a nematode? But also I wanted to thank Gabe for a great overview of the marketplace that we're dealing with. The California agricultural ecosystem is tremendous, and there are lots of players in it and lots of stuff that you can do. So back to what I was talking about originally, Pheronym is using pheromones to control nematodes. We got two products that we're working on. The first is a product we call Nematode. And what that does is it makes beneficial nematodes, which are already available for biopesticides all over the world, into better biopesticides. We roughly double their efficacy. We pre-treat them with the pheromone and spray them out on the field, and they do their thing. The treatment lasts for about a month, and then they'll be put out again. Then the other thing we have is Pheronym. The idea behind Pheronym is to protect plants from plant parasitic nematodes, which infect their roots and suck away everything. It reduces their ability to grow, and it reduces their yield. So we're making our pheromones using biomanufacturing, specifically fermentation. And we are using bioreactors to do that. We switched from using Shaker Plus, which is nice, but bioreactors let you scale much better. And now I come to how we're using AI. So there are lots of possible applications for AI, but the ones that I see us doing immediately are, first of all, streamlining our operation. We have a bioassay that involves counting nematodes. So the first thing we do is we call it a dispersal assay. The first thing we do is we put some nematodes down on a petri dish, agar plate, and then we let the water that they're in get absorbed. We add our pheromones to it and wait another 30 minutes to see if they're dispersed. After that, we either do a quick visual analysis and say it's dispersed or not, or we separate the ones that we think have dispersed from the ones we don't think have dispersed, and then count each segment or each set individually to give us a complete number of nematodes. Needless to say, this is time consuming and there's a big potential for error. So what we want to do is use a computer vision system to count the nematodes for us. We can already take pictures of these things, it's fairly easy. And as I said, just the evaluating whether or not it's dispersed or not is easy and straightforward. We could easily have an AI system set up to do that, but it's probably cheaper just to have people look at them really fast. Anyway, and then the other thing we can do with AI is use it for pheromone discovery. We're just focusing on one behavior of a few species of nematodes. That's dispersal. But there are lots of other behaviors and lots of other nematodes that we can work on. We want to work on plant parasitic nematodes. And so the biggest reason we start with dispersal is because one of the biggest pests nematodes is called rodent nematode. And it doesn't reproduce sexually. So there's no sex trapping, there's no sex masking. You can't hide the males from the females because there aren't any males. So we went with dispersal. But there are plenty of other nematodes out there that do use sex to reproduce. And we could do sex disruption with that. So that's what we're going to be using AI for in that aspect, is to find out new pheromones and new pheromone blends that can be used with the different nematodes. As far as career paths that are available, we have quite a few. At Pheronym, we are hiring people we're hiring a chemical biology research associate right now. We're looking for somebody with a PhD or who's about to have a PhD to join our lab. We're also recruiting interns. As Steve said, we're hiring an AIFS intern, and I've interviewed a few of you already. We also have NSF-funded undergraduate research experience interns that we are looking for. And if you're interested in the business side, we're always looking for business interns. That's my thing.
All right, we now have a remote speaker. Let's speak Ranveer Chandra, Managing Director with Research for Industry with Microsoft. And we're going to ask Ranveer if you could, if we're going to try to spotlight you here. And you can take it away, share your screen, whatever. So welcome, Ranveer.
Okay, wonderful. Yeah, happy Friday. And thank you for making it to this event. And thanks for having me. I would have loved to be there in person anytime to get away from Seattle to the sun that you're getting there in California. It's another cloudy day outside here in the Seattle area. So I'm Ranveer Chandra. I've been with Microsoft for 19 years now. This is the only place I work. My background is I'm a PhD in computer science from Cornell, but I've been leading this agriculture work at Microsoft, as Rikin mentioned, for the last 10 years. And this is a project I started here where, one of the questions you can ask is, what is Microsoft doing in agriculture and food? What's the why it's not something you would associate with anything to do with farming. So what we are doing at Microsoft, of course, we are not an agriculture company, but our vision is to bring the best of best of technology, best of data, best of cloud, best of artificial intelligence to agriculture. And our go-to market is through partners. Like, for example, we partner very closely with Rikin and his team at Digital Green on bringing some of the best of technologies to the farmers that Rikin works with. So what is our ultimate vision here at Microsoft? So, our goal is to help address the world's food problem. The world needs more food. It just doesn't need more food. It needs more nutritious food. And it needs this nutritious food without harming the planet. The soils are not getting any richer. The water levels are receding. There's climate change. So how do you get to this increased nutritious food production to feed the growing population of the world? Towards that, we believe one of the approaches to get there is that of a data-driven agri-food system. That is, if every entity in the agriculture and food value chain, from input companies to seed companies, tractor companies, farmers, food processors, the food logistics people, the retailers, the suppliers, the customer, if every entity started to use data and AI, it would lead to new efficiencies in the entire food value chain. But in fact, that's not enough. If you could start connecting the entire food value chain, if you could start sharing data across the entire food value chain, this leads to new efficiencies, new business models. For example, around food transparency, like track and trace, nutrition, sustainability, and others. And towards this at Microsoft, we've been building the tech platform to help us get there. We started with this project FarmBeats, which was about just a data platform for agriculture. What we started looking at was, what if you could start aggregating the data for any farm? What if you're given a polygon? A polygon could be a farm, a field, a plot. Then for that polygon, how do you bring all the data for that farm in one place, from satellites, from weather stations, drones, tractors, sensors, everything in one place? This project is now a Microsoft product called Microsoft Azure Data Manager for Agriculture. It's in public preview. We've announced partnerships. Land O'Lakes is running on this. Bayer, if you're in Europe, Bayer Corporation is building Bayer Ag powered services on top of this platform, which is Azure Data Manager for Agriculture. That's one key capability that we saw was a gap, was how do you bring the data from the farm to the cloud in one place? Once you bring the data, the next thing we started looking at was traditional artificial intelligence. How do you bring more, the things like deep learning or, CNNs, RNNs, LSTMs, all of these different ways to do analysis with remote sensing data, on-farm data, to things like, predicting the yield in a farm, or predicting the water stress, predicting the management zones, how much inputs should you apply in the management zones. So we built over 65 different AI workflows that we've open sourced. It's available on farmvibes.ai. If you go to farmvibes.ai, farmvibes.ai, it's on GitHub, and we continue to support it and keep adding more and more AI workflows for people to use. But we've been continuing to do that. But two years back is when the field of AI changed. I'm a computer scientist, and from our perspective, this entire field of artificial intelligence saw a big jump in what happened with the release of ChatGPT, and prior to that too, with GPT-2, GPT-3, and so on. The key thing that happened with artificial intelligence was then we saw the power of the scaling laws of AI. That is, if you start building these models, which is taking more and more data, more compute into account, these AI models could become more and more powerful. These pre-trained models, that is the PT and GPT, the pre-trained models became really powerful and really effective. So towards that, at Microsoft, Microsoft's pivoted, and everyone within Microsoft is using AI in some way or the other. Every product is being infused with AI. It's changing various functions. Like, I don't know how many of you use GitHub Copilot. Earlier, you had to write code. Now, all you do is write comments in English language, and it will spit out code that you can use. My team is able to do things in 1/5 of the time, like things that would take 5 days takes 1 day to do with GitHub Copilot. Copilot is now introduced in different things, like if you're using Teams, if you're using Word, PowerPoint, Copilot is everywhere, and Microsoft is moving really, really fast in this space. So as these things were happening, one of the questions that we also asked was, how is this going to impact agriculture? So towards that, one of the first things we did is we said, okay, for Washington State, let's just build a Copilot. What this does is, for Washington State, for every farm here, we try to store a farm context. The farm context, this is using Azure Data Manager for Agriculture. The farm context are things like, what is like when was the plant date, seed date, chemical application date, all the information about the farm, so that if you ask a question, what is the next intervention I should be doing in this farm or this field, it is able to then augment the prompt with this additional context, use retrieval augmented generation to come up with a response. That was the first thing we did. And then last year, I was in San Francisco when one of the venture capitalists, he asked me this question. He was like, hey, can you guys use GPT-4 to pass the agronomist exam? This is the Certified Crop Advisor exam in the US. So, prior to that on LinkedIn, there were certain people who were commenting that, this is not accurate, this is not giving me good results. So we went about this exercise, and we added context. We didn't fine tune, but we did other tricks. And using that in the US Certified Crop Advisor exam, we were getting 93% grades. In the Embrapa exam in Brazil, which were long form questions, we got 84% grades in the exams. In India, we got 79%, which was more than the number one human. So this then showed the feasibility of an AI advisor, an AI agronomist. But that wasn't enough. So then we said, okay, but it would still make mistakes. We're like, can we reduce the number of mistakes that these co-pilots make? So we went through that next exercise and said, what if we fine-tuned GPT-4 itself? That is, we take a large model and we modify the model. We fine-tune the model to adjust the weights based on agricultural data. So then what we did for that is we took data from USDA, from Embrapa, from India, and we then used that to fine-tune the model, which, as Rikin said, it's a very expensive exercise. We went through it. We wrote a paper on it too. We talk about the pipelines. We talk about the results. The results are very interesting. You get improvement in accuracy. But the particular result that got us very, very excited with fine-tuning was the ability of fine-tuning to... This is still in early stages, but it was very exciting. Like, for example, imagine a scenario where a farmer in India asks a question, I'm seeing these brown spots on leaves. What might be happening? What if the large model says, I don't know what's going on based on the data set in India, but your growing conditions match what the growing conditions are in Brazil. Based on that, this is what you should be doing in the farm. And we saw an early sign of this. We did a systematic study, which is there in that fine-tuning paper, for the 50 states in the US, where across all 50 states, we looked at questions that were similar across at least 3 states. We kept the information for 3 states and removed the rest. And then we saw the ability of fine-tuning to learn the information that was omitted from the training. So that's very, very exciting of the role that generative AI will play in transforming the entire field of agriculture and truly democratizing how we can bring data and AI to this field. But of course, and this is just part of it. The next stage of this is using multimodal AI. This is some work we again did with Rikin and team on not just text, but what if you could start using images? How would this thing work? Most recently, we did another work on small language models. That is, these large language models are good, but they're expensive. You can't run it on a phone. A lot of times you're disconnected in a farm. So the next thing we looked at was taking a small model and making it work for farmers. And here, what we saw was some of the results we were getting was as good as GPT-3.5, which makes it very, very effective and usable on the benchmarks that we run on agricultural data. So overall, we are very excited about all of this. And as I said before, we are not an agriculture company, but our goal is to build these tools and get it to market by partnering with organizations such as Digital Green We are very excited about the work you are doing at UC Davis. We work extensively with universities and would love to partner more deeply and engage with you and get all the latest tech as we are developing some of them. The thing I will say is, I'm very excited about this hackathon, the things that you will develop over the next few days. And, the great thing about everything with generative AI, over time, we have been working on various ways with a vision to take all of these technologies, digital technologies, to farmers. That's what we call our vision, is to democratize data and AI-driven agriculture. Until now, we had solved the data problem. We had looked at turning that data into insights. The last piece was missing. How do you take these things to a farmer who might not be literate? Their hands might be dirty. And generative AI helps us fill that gap. It meets a farmer where they are. They don't need anything else. All they need to do is just talk. And we can then convert that into information and get the insights to a grower. So we are very excited about the vision and the impact that it can drive, and looking forward to what all the work you would do over the next few days and ways in which we can partner. Rikin did ask me to mention a little bit about, what are some of the opportunities at Microsoft. At Microsoft, we are doing a lot on AI and interdisciplinary AI, industry AI. With agriculture, of course, there's agriculture AI roles. We work a lot on sustainability and AI. But at the same time, we also work on, agriculture when we think of agriculture, we think of 4Fs, 4 industries: food, feed, fiber, and fuel. That's, food is what we eat, feed is what the animals eat, fiber, what we are wearing, and fuel, the ethanol that you get in the gas stations. All 4 originate from the farm. So the work that you're doing, one advice for you would be not just thinking of what you're doing on the farm, but the downstream applications of that as well. And that might open up a lot of new opportunities. Of course, agriculture, there are a lot of opportunities directly, but the applications, and especially the applications of AI in agriculture and the impact it will have downstream, might open up a lot of new opportunities as well. So look forward to staying in touch with many of you. Do feel free to add me on LinkedIn, and would love to see what you all come up with. Thank you.
Thank you, Ranveer. All right, that concludes our speakers. We thank Ranveer, we thank Gabe, we thank Karl, and we thank Rikin for their talks today. Thank you all.